Uh, Good afternoon, everyone. I want to welcome you to a revision week. And of course, today, what we're going to do today and Wednesday is very, very crucial. Uh, I need you to pay attention. I actually made an announcement, if you check announcement section this morning, you know, when I officially became a college, a lecturer in 2012 at the University of Ibadan, Nigeria, I promised that I was going to have a listening here. Now I'm going to listen to my students. When I joined the services of the University of Minnesota in 2018, I renewed the promise that I was actually going to have a listening here. The reason why I made the announcement this morning, because I listened to students. Some students actually provided me feedback about possibility of conflict. And because of that, I became more flexible. This exam will be officially open 6 a.m. Please, I need you to listen, okay? 6 a.m. on November 17th, and it's going to be left open until 11:59 p.m. on November 17th, which means you can choose to start at any time you want to start, but except that you can only spend 75 minutes on the exam when you choose to start, and those who have accommodation later we actually spend 2 hours. I did that because I don't want a situation where conflict will mitigate your performance in midterm 2. And that was why I became more flexible. I believe that flexibility will give you, more room to be able to take the exam. Does that make sense, right? Okay, so it's going to be a remote exam. It's good, like I said, you will receive a notification just the same way you receive weekly assignment. But if you have not made up your mind, don't click. The moment you click on that, your time is going to be running out. So I need you to plan wisely. It's going to be open 6 a.m. on November 17, and it will automatically log out by 11:59 p.m., not a.m., 11:59 p.m. in the night. Does that make sense? Okay, you're going to log on to the Zoom. Today, you're going to receive the Zoom link. It's the same class link that is on Canvas with your video on, but you need to be muted, whenever you want to start, even though I may not be on the Zoom, but it's being recorded. You are allowed 2 sheets, 2 pages of notes. Okay? 2 pages of notes. Okay? And I'm going to tell you what you need. You are not allowed to communicate, to share, because I know some of you will write the exam at different time. You are not allowed to share any information about the exam with your fellow students. No form of assistance. Okay? We got a way to track that. The midterm 2 will cover chapter 4 to 6. Today, I'm actually going to review chapter 5 and 6. On Wednesday, that's chapter 4. I've already uploaded the practice questions. Okay? Now, we're going to have 30 multiple choice. Chapter 4, chapter 5 and 6, 15 questions will revolve around chapter 5 and 6. Chapter 4, we have 15 questions. Immediately you submit your exam, you will receive your score automatically. Does that make sense? So what I need from you today, I'm going to start my review. I'm actually going to start my review from chapter 6. Today, I'm going to do chapter 6 and chapter 5. Then on Wednesday, I'm going to do chapter 4. But you know what I need for any question before I go into review? Go ahead. Which, you know, when you log on to Zoom, I want to see you with your video on. Yeah, that's how you're going to have a link. It's the same class link that will be shared. I'm going to share that link again today. And when you log on to Zoom, you need to be muted because there could be other students in the Zoom. Okay, after go ahead. 6 a.m. You said, when is it going to be visible, right? Eh? Oh, what if you are invisible on the camera? Is that what you mean?
What does the camera need to be looking at while we're taking it?
Yeah, yeah. You have to show yourself. You need to be visible. Okay. I think I just want to, of course, when you appear on Zoom, you know, we normally want to see your face to be able to know it's you. You may not show your hand, but I'm going to know. There's a way I can track the environment. Have I answered your question? You need to be visible. I want to see your eyes. Does that make sense? Yeah.
You said we could use like the gamma beta, or I don't know if it was gamma or beta, but you can use the oscillator, so how
During my review, I'm actually going to tell you those tables, whether it's going to be online or it's going to be maybe in a statistical table. During my review, I'm actually going to tell you all of that. Have I answered your question?
So we can have the textbook like open.
Exactly. But I'm still going to give you further information about that. Go ahead. Yeah. Like, you say that again? Yeah. Like a blank piece of paper where you can just do some workings. Yeah, that's allowed. You're allowed. Well, I know some of you will do some workings. Okay. Now, you know what I need you to do now? I want to assure you this. If you follow what I want to do now, you will score more than A in this exam. I just need you to focus on what I want to start with chapter 6. Okay, chapter 6. I want to start with chapter 6. Chapter 6 focus on continuous probability distributions. Okay, now, number 1, distribution, uniform. Okay, now if X follow uniform, we parameter this. Okay, f of X equal 1 over beta this, where X lie between this and this. The expected value of X is alpha plus beta over 2. The variance of X is beta minus alpha all squared over 12. Now, this is uniform. And you know what? Under the uniform, they can ask you to find the probability of S less than A, maybe a particular value. This is the same thing as this. So what they are asking you, okay, you start from the lowest, alpha, to that particular value. Then you integrate that. They can also ask you S greater than A, which is the same as this, which is A to that f of S dx. you can also be asked, S lie between A and B is the same as this, is the same as this, okay, is the same as this, okay, which is A to B, f of s, ds. I'm done about uniform. Now, when you take a look at the uniform now, right? When you see something like this, it means follow uniform. This is a PDF. This is the mean. This is the variance. Then these are the possible things they can ask you to find. What is the probability of x less? Less is the same thing as less or equal to in continuous. You're going to start from the minimum. Minimum, they specify for uniform. You're going to stop at the point A. You're integrating f of s. What is your f of s? 1 over beta minus alpha. Okay? You can be asked s greater than A. Is the same as that. Greater than A. You are starting from that A, and you're going to end up in the upper bound given. Okay? Then you can ask you to find s lie between two constants. Okay? So whether this, that, or that, they are all the same, then you're going to use that f of s ds. And your f of s is 1 over beta minus alpha. Any question? Any question on that? Now, I forgot to tell you, this is being recorded. What I'm doing now is being recorded, and I'm going to share the recording before the end of today. Does that make sense? You can watch the recording, for you to be able to, like, if you miss anything out. Now, that is uniform. Any question on uniform? Any question? If I were you, these are the kind of stuff you can write on the notes. Okay? These are the kind of stuff you can write on the notes. Okay? Now, I want to go to another distribution if there's no question on the union. You can take a picture if you like. Okay? But like I said, this is being recorded. We use uniform distribution when events in the sample space has equal probability of being, of occurring. That's why it's called uniform. They are equally likely to occur. That's what it means. And that is why the f of s is going to be a constant. The f of s is going to be a constant. Even when I know the lower bound and the upper bound, I'm fine. And you're actually going to see the mean, the variance. They are all functions of the lower bound and the upper bound. Okay? Now I want to go to another distribution now. Now, the next distribution I want to talk about is normal. Normal. Okay? Now for normal distribution, okay, x follow normal with parameter mu and this, f of s equal 1 over square root of 2 pi sigma squared. Then this x minus mu over sigma squared. S lie between negative infinity to that. Okay, the expected value of s is mu. The variance of s is sigma squared. The standard deviation of s is sigma. Okay, now they can also ask you to find, okay, they can ask you to find stuff like this. They can also ask you to find stuff like this with the normal. But if you want to find stuff like this with the normal, you need to be able to find z, like when they talk about that, okay, z, maybe you got a particular value, okay, for z, maybe I call that A1, then we're actually going to check from binomial table. Okay, this is like check from binomial table when they talk about less than. When it is greater than, it's going to be 1 minus whatever I check. Okay, this is like checking, okay, from table. Okay, when it is greater than A or greater or equal to A, I'm going to subtract whatever I check from table. Then for in between, okay, I actually need to use this x minus, I'm going to do b minus mu over sigma minus a minus mu over sigma. Okay, this check. Also check. Okay, now if b, maybe they say between 50 and 70, this is going to be 70 minus, they're going to give you the mean. They're going to give you the standard deviation. Whatever you get here, you're going to check that value from the normal table. Then we're also going to do the same, check from the normal table. Then you subtract. Okay? I'm done with normal. Go ahead.
We're going to be given the normal probability table?
Exactly. You're going to be given. That's a good question. Of course, because you're going to be writing the exam anywhere you choose, then those are the, I'm going to tell you the kind of things you need. Does that make sense? You're going to have access to that. That's a good question. Any question about normal? I'm done with normal. I'm done with normal. You have any question? You ask me now. Okay? A normal distribution, of course, a very good distribution, it depicts, most of natural phenomena. Okay? Talk about income, talk about height and so on like that. So take a look at all of that. So with the normal, we're actually going to make use of a table, a statistical table. Now, after normal, I think I'll go ahead.
I just got to read that symbol at the f of x. It's 1 over square root 2 minus sigma squared. What's that symbol right there?
Which symbol? Is it right here?
No, it's in the, right there.
Yeah.
No, the one after.
Is it this one?
No.
Or 2?
Right before that.
Exponential.
Okay, thank you.
Yeah, it's exponential. Exponential. Okay, now, uniform, normal. We're going to go to the next one now. We want to go to normal approximation to binomial. Normal approximation to binomial. Of course, De Mover in 1733 introduced us to that. Now, this is the situation. If x follow binomial with parameter n, p, let's say initially s follow binomial. If np is greater or equal to 10, and n into 1 minus p is greater or equal to 10, okay, if this condition hold, okay, then x will now follow normal with the mean np variance this. Okay? So if this condition hold, binomial will behave like a normal distribution with the mean of np, the variance of that. Now, if they ask me a question here, I can make use of a z-score where I'm going to have x minus, what does it mean? np divided by the standard deviation is going to be square root of np into 1 minus p. Okay? Now, if I want to use a normal approximation for binomial, okay, don't forget, any approximation will lead to, there's going to be error. How can we control the error? Because of that, we consider continuity correction. Okay, we consider continuity correction. Now, in a situation where they ask you to find s greater than a, okay, s greater than a, what is the opposite of this? X less or equal to a. So this is going to be s greater than a plus 0.5 and s less or equal to a plus 0.5. So let's say in binomial, they ask you to find probability of s greater than 5. S greater than 5. If you want to use normal approximation, it's going to be s greater than 5.5. You're going to add 0.5. If you want to do s less or equal to a, It's going to be that. So what about x less than a? What is the opposite? S greater or equal to a is going to be x less than a minus 0.5 and x greater or equal to that. Okay. What about situation where s equal to a? Exactly a. Then that is going to be, okay, s lies between a minus 0.5, a plus 0.5. Okay, so what about situation where, a less than x, less or equal to b, or what about situation where a less or equal to that, this less or equal to that, okay? Now, here, I'm actually going to have, let me see, less or equal, okay, a plus 0.5. So a plus 0.5, okay, less than s, less or equal to a b plus 0.5, okay, and here is going to be a minus 0.5 less or equal to s less than b minus 0.5. Go ahead.
Why are the continuity fractions for the second and third different quantitatively? Like, why is the second one plus 0.5 and the third one minus 0.5 since they're both versions of less than?
That's a rule. You know, statisticians, we've done a lot of things behind the scene, and we realize that this is the approximation that will lead to, that will enable us to minimize error. Okay? So we've done that behind the scene. So how did I get this? Take a look at this. They are opposite, right? Greater than, opposite is this. It's going to be the same thing suggested. What about this guy? What is the opposite? It's going to be the same thing. That is a trick. And when it's equal to, I'm going to do something. They normally call it robbing somebody to pay another person. 0.5, adding. Well, that's what it says exactly. Then what if in the situation, if you take a look at this, if you look at the upper bound is less or equal to, come back, less or equal to here, adding, less or equal to, adding to both sides. Okay? Now, what is it? Lesser. Show this here. What do we do? Negative, negative, negative. You're welcome. Okay? Now, I'm done. Everything that you want to do here, don't forget, you need to determine what is your N and what is your P. Okay? And you're going to check from table. Now, this is normal approximation, okay, to the binomial. So we've done uniform, we've done normal approximation to binomial. We've done 3 now. We left with exponential, gamma, and beta, and log normal. Okay? 4. We left with 4. Okay, now I want to go into let me just tell you this. I'm not going to set a question on log normal. Okay? A little bit advanced. I'm not going to set a question on log normal. Does that make sense? Okay, now let me go to exponential. Okay, x follows ESP with parameter beta, f of s equal 1 over beta this. Okay, x greater than 0 and beta greater than 0. This is an exponential distribution. We use exponential distribution to model waiting time before the occurrence of an event. How long am I going to wait? Before this particular bulb will not functioning again. Okay? But this is for one item. Okay? Now, here, the average, maybe I want to get the mean life, or average time to wait before the occurrence is actually beta. Then the variance is beta squared. Of course, the standard deviation is going to be beta. Okay? Now, you want to find You want to find the probability of S greater or equal to A, or you want to find the probability of S less or equal to A. You know, this is the same thing as S less than A. This is the same thing as S greater than A. Okay, now it means I'm going to go from 0 to A, okay, f of x dx. Okay, here I'm going to go from A, okay, A to infinity f of x dx. Okay, and I may also want to find, okay, between A and B, okay, A to B, f of x dx. And don't forget, this is your f of x. That is your f of x. Okay? So take a look at that. Okay? This exponential distribution. Okay? Now, go ahead. Exactly. You can also do that. You know, here, what that excellent guy is talking about is, I can do 1 minus this. Okay? For greater than. Okay? That's correct. Yep.
The antiderivative is always going to be negative e to the negative x over beta, right?
You mean inside the, you mean which one? Is it?
When we take the antiderivative of f of x, it's always going to simplify to negative e to the negative x over b, correct?
Oh, okay. So you mean if you take the antiderivative of this, for instance, I'm going to put this guy outside. I'm going to have this guy, dx, right? Now, you need to remember this. If k is a constant, that would be this, right? Now, what is a constant here, apart from x? That's going to be negative 1 over beta. So if I'm going to have this guy divided by negative 1 over beta. You see that?
So that it cancels it.
Then minus, right? Then I'm just going to, does that confirm your
That's what I was, yeah.
good job? That is it. Okay, this is the exponential. Just take your time. It's easy. The exam is going to be easy. Just take your time. Okay? Now, I want to go into gamma now. I want to go into gamma. You know, gamma is a generalization of exponential. We're actually having more than one item. We're still talking about waiting time before the occurrence of an event. How long am I going to wait before this event will occur? Okay, but this time around, the numbers of items is more than one. Okay, so x follow gamma. We parameter this. You remember in exponential, we only have this parameter. But in gamma, we got this guy now. Okay? And when alpha equal to 1, this gamma will become exponential. Okay, so let me write, what is the density function? Okay, minus, right? Then I'm just going to, does that confirm your
That's what I was, yeah.
good job? That is it. Okay, this is the exponential. Just take your time. It's easy. The exam is going to be easy. Just take your time. Okay? Now, I want to go into gamma now. I want to go into gamma. You know, gamma is a generalization of exponential. We're actually having more than one item. We're still talking about waiting time before the occurrence of an event. How long am I going to wait before this event will occur? Okay, but this time around, the numbers of items is more than one. Okay, so x follow gamma. We parameter this. You remember in exponential, we only have this parameter. But in gamma, we got this guy now. Okay? And when alpha equal to 1, this gamma will become exponential. Okay, so let me write, what is the density function? Okay, this. Take a look at that. When beta equal to 1. Oh, sorry, when alpha equal to 1. When alpha equal to 1, it's going to be 1. 1. I'm just going to have exponential density. Okay, so what is going to be the mean? Alpha beta. What is going to be the variance? Alpha beta squared. What is going to be the standard deviation? The square root of that. When alpha equal to 1, it's going to become the mean of exponential. When alpha equal to 1, it's going to become the variance of exponential. And when alpha equal to 1, it's going to become the standard deviation of that. And in the case of this guy here for gamma, they can ask you to find all of this. But you know what? The density function is complicated. Then we're going to make use of a table. I'm going to show you. Go ahead. What is which one? Is it this one? Gamma. Gamma alpha. Gamma alpha, this is called gamma alpha, which is the same thing as this. Alpha minus 1 factorial. Okay, gamma alpha the same as alpha minus 1 factorial. So we're going to make use of a table in the gamma. I'm still going to show you. We're going to make use of a table here because if you want to go by way of calculus for this is complicated. You can still go by way of calculus for exponential. That would be super easy. But for this guy, it will be complicated, and we're going to make it of a table. Does that make sense? We're going to make it of a table. The last distribution is beta under the continuum. Like I said, I'm not going to set question on log normal. Okay? So that means it's just going to be 5 distribution for under continuous uniform, normal approximation, okay, normal, exponential, gamma, okay, beta. Oh, that would be 6. I think how many decisions have we done today? We've done uniform, right? Uniform number 1, normal number 2, normal approximation number 3, exponential. Oh, we've done 5. Okay, we want to do the 6th one, which is going to be the last one. We're not going to do log normal. Okay, now we want to do the last one now. And that last one is beta distribution. And that very distribution is very, very important when the random variable is a rate or proportion. Okay, you know, every other distribution will be doing other continuous. The range of the state space of X, you know, lies in real number, you know, but for beta distribution, okay, the random variable here, okay, is proportion, okay, or rate, okay, and if X follow beta, okay, with parameter alpha beta, okay, then f of x equal x raised to power this 1 minus x raised to power this divided by b into alpha beta. X lie between 0, 1, alpha greater than 0, beta greater. This is the density function of a beta distribution. Don't forget, the range is in 0 to 1. Okay? This distribution, I can use it to figure out what is the probability that the customer satisfaction rate will be more than 60%. It is not all the customers that will prefer my service or that will prefer my products. Or what is the probability that approval rating of a president will be more than 50%? You know, when a random variable is proportion, rate, percentage, Okay, proportions, rate, percentages, they're all going to be between 0 and 1. Okay, 100% is 1, 0% is 0, 90% is 0.9. Okay, now what is the average? Maybe I want to know the average customers rating of my products. Okay, now alpha, this is the mean of a beta distribution. So the moment I know alpha and beta, I'm just gonna use that to find my mean. Alpha over alpha plus beta. Then the variance, that is the variance. Okay, alpha beta divided by alpha plus beta all squared multiplied by alpha plus. You're going to see that the mean, the variance, the distribution, all depends on parameters alpha beta. Now, let us assume that, and don't forget that this guy here, I told you the other time, B of alpha beta is gamma, gamma alpha, gamma beta over gamma alpha plus beta. So which is alpha minus 1 factorial, beta minus 1 factorial divided by alpha plus beta minus 1 factorial. I'm talking about the denominator here. Now, if I want to solve it, let's say for instance, I want to calculate the probability that more than 60% of customers like my product. More than 60% of customers like my product. I want to find the probability of S greater than 0.6. Or, this is the same thing as this. What am I going to do? Okay, before I can do that, the examiner will give you what is alpha, what is beta. Okay, let's say examiner give you 2 and beta to be 5. I'm just assuming. Examiner give you that. Now, what do you want to find here? Greater, or want to start from 0.6 to what? To 1. To 1. Okay, then you want to make use of this guy. You're going to plug in the alpha beta given. Okay, now, if I plug in alpha beta given, I'm actually going to have this. But you know what? This will be too complicated. Then I'm going to allow you to use an online calculator for beta, which I'm going to show you. Now, I'm done with continuous probability distribution. My remaining time, I want to show you examples from the practice questions that I uploaded the other time. Okay, give me 1 second. Let me see where. Okay, it's right here. Now, I'm going to go into let me first start with beta. Do you see that question? Do you see that question? A restaurant hosts a special. Can everybody see that question, right? Question 11. This is in the material.
Shouldn't the bottom be beta 2 and 5, not 1 and 5?
Oh, you are correct. Because alpha is 2. That is correct. Here. And here, this is like 1. Got 2 minus 1. 5 minus 1. Good job for catching that. Okay. Now, is everybody seeing beta distribution now? So everybody seeing that? Okay, what happened here? A restaurant hosts a special event once a month where a proportion, okay, of the proceed hand is donated to local charity. If the proportion donated to charity is molded by bidder distribution, of course, anytime you hear proportion, rate, percentages, it can be molded by bidder distribution. Okay? Now, they gave you 1 and 5, right? Alpha equal to 1, beta equal to 5. What is the probability that 30% or more of the restaurant earnings will go to charity? What did they want to find? The probability of S greater or equal to 0.3. Does that make sense? Now, don't come here. It's going to waste your time. Now, I'm going to open. Do you see that? That is beta distribution. That's an online calculator. This calculator is expecting you to put what is the value of alpha, what is the value of beta, okay, and indicate your x. My x here is 0.3, right? 30%. I'm going to put 0.3. Now, when you take a look at this, you're going to see two things, greater than and less than. Does that make sense? So which one do you want to, which one are they talking about, greater than? I'm just going to choose this one. Then I compute that. That is the result. What is the result? It's 0.16. Hey, I'm done. With online calculator, what did I just do? I save you from, if you use this, it will take for it. Go ahead. Yeah, I will do that. Like today, that's a good, the link, I'm going to, if I want you to use online calculator, for us to be able to get the same result, because there's different kind of online calculator, today, I'm actually going to share the link for the online calculator I want you to use. Does that make sense? Is this not super easy? This is super easy. Any question? Go ahead.
So are you going to tell us which distribution to use? Because in that question, it tells you to use beta, but are we going to know which distribution on the test?
That's a good question. Whether they're going to tell you, like, whenever I set a question on continuous probability distribution, I will mention the distribution. Because you know why I'm going to mention that? Because there are some distribution, 2 or more distribution may perform the same role, like exponential gamma. Does that make sense? Okay. Now, which means but you cannot use this calculator. You cannot use it to find the mean and the variance. You need to use this formula. This is going to be simple computation. The moment you know the values of your alpha and your beta. Go ahead. Huh? Oh, I can see it's right here. Oh, okay, go ahead. Go ahead. Yeah, that makes sense. Okay, but just know that. You can check that. Do you want to try it now? 1 divided by, let's try it. 1 over 1 plus 5, right? What is 1 divided by 6? Does it give that? Oh, start celebrating. That makes sense. Okay, with beta distribution, you should be fine, right? Please don't waste your time. Don't come here. Don't waste your time. Okay? Now, we're going to go to gamma now. With the gamma, we're going to make use of a table. Let's go to the gamma question. Take a look at this. You remember a question like this? Okay? Just like what you told me, you said the other time, right? We're going to be told. Like, take a look at question 10 on gamma. You were told that what? The product is a gamma distribution. Okay, when you have the alpha, you have the beta, right? And right here, they ask you to find, following this change 20 months pass before the first complaint, does it appear as if that means 20 months passed? So that would be greater, okay, than 20, which means they want you to find this guy, But if you want to go by rigorous calculus, again, don't attempt to go by rigorous calculus. What are you going to do? What you're actually going to do is take a look at this guy. What is your x? 20. What is your beta? What is your beta? 4. What is 20 divided by 4? 5. Right? Then, take a look at this. This guy means f, okay, x over beta. If you want to talk about formula, comma, alpha. That is what I'm going to check. It means I will check 5 and 2 in a gamma table. 5 and 2. 2 is what? Alpha. Now here they say greater than. It's going to be 1 minus, because that's F5 and 2 is less than. I'm going to do 1 minus that. So let me take you to gamma table. Okay, we want to go to gamma table now. Okay, we want to check for 5 and 2. You know, for 5 and 2, we're told it's going to be 0.96. Give me 1 second. Let me see. Okay. Where are you, gamma? Time is going. Gamma, show me, show now. I'm going to go to gamma now. Let me see, gamma. Okay, I think I'm going to be going down. So this is from the textbook. Okay, so I'm going into gamma now.
It's just control
Huh?
F. Just control F and then type in gamma.
You saw what?
It's 23.
23, right? What do you call 23? Oh, is it 723? Oh,
The table.
8.23? Oh, that's going to be so down. Thank you. Maybe I'm getting old. Let me see. This is 8.6. Oh, this is 8.3. 8.23. That would be so. Okay, 23. Oh, this is 21. Okay, we're very close. Very close. Oh, okay, it's right here. Now we're looking for 5 and 2, right? Okay, 5 and 2. Okay, this is alpha, right? Okay, so if that is alpha, okay, alpha equal to 2, s equal to 5. What is that? Do you see that? Do you see the way we just checked that now? Don't forget that formula for less than. That formula for less than is this: x over 2 alpha. Okay? Let me just say x over beta alpha. Okay? So 5 and 2 is 0.996. If you take a look, that was why we got the 0.96. Go ahead. You say what? Yeah, so the one you check from the table is less than. But the question is talking about greater than, then you're going to do 1 minus that. Where? No, this one is less than is just what you check from the table. Does that make sense? Well, less or equal to or less than is the same in continuous. Greater than or equal to is the same. I want to believe today you should have confidence about continuous probability distribution. You're actually going to say the questions is just going to revolve around. Well, we're going to continue with this on Wednesday. Is there any question before I go today? Okay, make sure you stay safe and have a lovely day. Bye for now.
Hey,
midterm, like remake or whatever that you had the multiple choice questions. Is it possible to look at that even if we didn't want to take it? Like I got 100% on the first midterm, so I didn't take it, but I just want to look at those questions.
You don't. Oh, you just want to look at it.
Yeah,
Makeup.
yeah, just to
Oh.
see like how you have your multiple choice.
Okay, maybe later after the midterm too.
After midterm too.
Yeah, because what we did in the midterm one, the area cover in the midterm one is different from the one cover. Like the question is going to look more or less like you know what it's going to be different. Maybe the alpha and the beta will be different.
Yeah.
And maybe it's not going to be 20,
Yeah.
but it's just going to be the same